Okay, today we are doing sum and difference formulas for trig. These formulas would be ones that you would not be required to memorize. This would have been the first day of not putting in the bag of tricks. That's why you'll not see them in the bag of tricks. We have cosine of alpha plus beta, which is sort of like distribution, but not totally. Cosine alpha, cosine beta, minus sine alpha, sine beta. Cosine alpha minus beta. Alpha and beta are angles. We will be substituting in pieces for those. Cos alpha, cos beta plus sine alpha, sine beta. Sine alpha plus beta, they split out differently. Sine alpha cos beta plus cos alpha sine beta. Sine of alpha minus beta equals sine alpha cos beta minus cos alpha sine beta. We have tangent ones, which look much more complicated because tangent is more complicated than sine and cosine. So tangent alpha plus beta, tan alpha plus tan beta over 1 minus tan alpha tan beta. Once again, these are formulas you'll have at your discretion. They are already on the test proper that you will be taking starting this week. And then tan alpha minus beta. Tan alpha minus tan beta, 1 plus tan alpha tan beta. So an example of something we could do with this would say find the exact value of cosine 75. So as soon as I say exact value, it means you cannot touch your calculator. Because if you go to your calculator and hit cos 75, you're going to get a nasty decimal, which is not allowed. So exact values mean you have to go straight to the chart if they are chart-worthy angles, or you have to go to Pythagorean theorem. No calculator allowed. So for cos 75, we have to think about what angles from that chart can we use that add up to 75. So we have cosine of 45 plus 30. So it could be 30 plus 45, doesn't matter. So it's 45 plus 30. And I'm going to call that 45 the alpha angle, and I'm going to call the 30 the beta angle. So then we're going to go back up here and find the plus for cosine. So we look through the list until we find the plus for cosine, which is the first one. So we have cosine of alpha. We called alpha 45, so cos 45. We have cosine of beta, which we called beta 30, so we have cos 30 minus from the formula. Sine of alpha means sine of 45, and sine of beta means sine of 30. Now there are 4 distinct pieces here. We have 1, 2, 3, 4. So I automatically put in 4 parenthesis sets with the minus sign in between them. We then go to the chart and read the chart. So cos of 45 on the chart is rad 2 over 2. Cos of 30 on the chart is rad 3 over 2 minus sine of 45 is rad 2 over 2. Sine of 30 is 1/2. Now recall, when you multiply radicals, if they are not the same, the radical cannot disappear and you simply multiply underneath. So rad 2 times rad 3 is rad 6. 2 times 2 is 4. Minus sign. Rad 2 times 1 is rad 2. 2 times 2 is 4. This is as far as I want you to go. Do not try to clean it up, because if you try to clean, you oftentimes make mistakes. Just stop. Example number 2. Find the exact value. So as soon as you see exact value, it means you're working with the chart and or Pythagorean theorems. But sometimes you have to think a little bit outside the box and go, okay, what's happening here? So my original question to you would have been the black marked things. Cos 70, cos 40, plus sine 70, sine 40. But then I would say, okay, this is cos cos, hence that's why they're red underlined, and this is sine sine with a plus. So you go back up to the formulas, and you have to look for the expanded sides until you find cos cos. So that only occurs on the top 2, cos cos, sine sine, and then you have to figure out which one has the plus. Cos cos plus sine sine. You walk back over here and you see that that is cosine of alpha minus beta. So we're going to write that here. Then we have to figure out in this expansion who is in the alpha spot and who is in the beta spot. So when we go back up here, we'll see that this is 70, 40. So when we go back to the formula, 70 replaces alpha, 40 replaces beta. So we come down here, so we have 70 minus 40, because this is the formula we chose. It was the first one, right? No, second one. Second one. So it was the second one. So then we do 70 minus 40 is 30. Voila! Cos of 30, back to the chart. Rad 3 over 2. Done. Example number 3 says, suppose that the sine of alpha equals 4 over 5. Automatically, not in the chart. In quadrant 2. And cosine of beta equals negative 12 over 13 in quadrant 3. Notice I did not say parking lots, I said quadrants. Quadrants are for ASTC. Parking lots are for little raised inverses, of which there are none here. So let's find the exact value of. We have many exact values. I would want you to find cosine of alpha, cosine of beta, cosine of alpha plus beta, sine of alpha plus beta, and tangent of alpha plus beta. So, first thing we have to do, whenever we have non-chart numbers, is make their triangles. And you have to be very cautious to make sure that you make your triangles in the appropriate quadrants with the appropriate angles so that you can read which one you're doing. So I have sine of alpha in 2. So here's the picture for that. So quadrant 2, draw your right triangle, starting here, up, down, box that's on the x-axis. Now we would normally throw a theta in here, but we have to be more specific now. It's alpha, and that's a tiny little alpha there. It looks like a fish. So sine is opposite 4 over hypotenuse 5. We have to figure out the number, Pythagorean theorem, or just knowing it is 3, and then we say who is negative by common sense. The answer is negative 3. The alpha triangle is drawn. Over here, we have to draw our beta triangle. So the beta triangle says we're in the third. So we draw out and down, we make a right angle box. There goes beta, right in where we normally would have put theta. It says cosine is negative 12 over 13. Once again, we're going to put in numbers and then determine who's negative. So, according to SOHCAHTOA, cosine is adjacent, 12 over hypotenuse, 13. Then we have to go do Pythagorean theorem. We find 5. Then we do who is negative by common sense. Left, so it's negative 12, down, negative 5. Recall that the hypotenuse piece is never negative. Here's our beta triangle drawn. Once the alpha and beta triangles are drawn, it is a piece of cake. We use formulas which will be given to us on tests and other things. So when we come over here, cosine of alpha. So we go to the alpha triangle. Cosine is adjacent, negative 3, over hypotenuse, 5, negative 3/5. Cos of beta, you can go to the triangle, or it was given to you. Cos of beta, here's beta, cosine is adjacent, negative 12, over hypotenuse, 13. For cosine of alpha plus beta, you cannot add these two numbers together. It doesn't work like that. Cos of alpha plus beta makes us go all the way back up to this list. So cos of alpha plus beta is the first one. So we have cos alpha cos beta minus sine alpha sine beta. That's all of this written here in the red. Now just like up here, when we have 4 trig words, we have to have 4 parenthesis sets. 1, 2, 3, 4. So I always write in the parenthesis sets first. That's why they're in red here, because they kind of follow along with the formula. Then I fill them in with green from the triangles. So cos alpha, you go to the triangle. It is negative 3 over 5. Cos beta, negative 12 over 13, minus from the formula. Sine alpha is 4 over 5, and sine beta is negative 5 over 13, filled in the other two. Now it is a case of basic math. You cannot punch these fractions into your calculators. You have to do old-time math multiplying. So in the first one, negative 3 times negative 12 is 36. 5 times 13, 65. The minus from the formula comes down. Then we have 4 times negative 5, which is negative 20. 5 times 13 is 65. Minus minus in the center turns to adding, so 36 plus 20 is 56. Worked hard to get those denominators, 65. Do not reduce until the end if you can, and this one doesn't. Sine of alpha plus beta, you go back up here. Sine of alpha plus beta is this expansion, sine alpha cos beta, plus cos alpha sine beta. So here they are in red, what I just read. You would take it from your cheat sheet, for lack of a better word, down here. Once again, we have our red pieces, and we're going to fill them in. I changed to purple because it was a little better than the green. So sine of alpha, go to the triangle. Sine of alpha is 4/5. Cosine of beta is negative 12 over 13. Same numbers, just different parenthesis spots. Plus, cosine alpha is negative 3 over 5, and sine of beta is negative 5 over 13. Math again. 4 times negative 12 is negative 48. 5 times 13 is 65. Plus, negative 3 times negative 5 is 15. 5 times 13 is 65. Worked hard for the bottom, we'll keep it at 65. Negative 48 plus 15 is negative 33. The last piece I wanted you to find here was tangent of alpha plus beta. Now when we go up here and look at these tangents of alphas plus betas, they are very complicated formulas. So we are allowed to take a shortcut only when we pre-made cosine and sine. So if the tangent piece that I give you, alpha plus beta, matches your sine, alpha plus beta, cosine, alpha plus beta, we're allowed to take the ultimate shortcut. And the ultimate shortcut is to take sine over cosine. So we're going to take the sine that we found here, negative 33 over 65. We're going to take the cosine that we found here, 56 over 65. You will see that the bottoms match. We talk about this all the time. If we have fractions where the bottoms match, 65s are gone. So the answer to tangent is negative 33 over 56. Shortcut, ultimate rule. Do not use the formulas if you have pre-made sine and cosine. Now, we have something called verify. So we are going to do verifying problems here, and the verifyings are proofs, baby proofs. So they're not terrible, but they're proofs nonetheless. These aren't bad at all. We're going to do some a little bit later today that are a lot worse than this. But these proofs aren't bad because we use the formulas, which are on the front, so you'll have to trust me on it because they're now gone. And we have to sub in stuff from the chart and otherwise. So here we go. Verify. When you see the word verify, it means prove. So that means you can only work with one side. So my original basic question is this. Let me cover this up here. My original question would be this. So cos of alpha minus beta over cos alpha cos beta equals 1 plus tan alpha tan beta. So the first thing I have to do is realize that whenever I have an alpha minus beta, that's problematic. It's probably going to be something that I have to go find a formula for. So we do. So we go find that formula. Cosine of alpha minus beta is replaced by cos alpha cos beta plus sine alpha sine beta. Same bottom. Cos alpha cos beta, or times cos beta. This side we don't write anything because we have to prove this side. Cannot change this side. Have to work down to it. So then we'll notice that this is one of those things that we talked about way earlier, that we spend our entire mathematical life when we're younger putting common denominators together, but there is that rule where it oftentimes is easier to split the common denominator up. And we've done this before. So we are going to split this cos alpha cos beta divided by this, plus sine alpha sine beta divided by this. So here we are, cos alpha cos beta divided by cos alpha cos beta, plus from the upper piece of the formula, sine alpha sine beta divided by the same bottom, cos alpha cos beta. Now the really cool thing over here is, once you get here, cos alpha are the same, so we can cross them off. Cos beta are the same, so we can cross them off. That's the cancel part. Over here, we're going to see a different representation. You can see where my arrows are here. Sine over cosine is tangent alpha. Sine over cosine is tangent beta. So we come down here. The cancels are all gone. In division, that's 1 plus tan alpha tan beta was an exact match to the other side. Put a little check mark, not required, but you can do that to say to yourself, oh yeah, right, I'm done. Last one we're going to do is example number 5. This would have been your original problem. Verify the identity. Tan of x minus pi over 4 equals tan x minus 1 over tan x plus 1. So unfortunately, no shortcut this time. No shortcut. We didn't have sine and cosine of it, so we can't take the shortcut. We have to use the formula. So we have to take the formula where we had minus between our two angles. So here it is. And what happens is you have to separate it out. This is alpha. And alpha becomes x wherever it is. And beta becomes this. So this is alpha and this is beta. So when we expand it, every alpha becomes x, so tan x, minus every beta becomes pi over 4, so tan pi over 4. Bottom. 1 plus, remember these formulas were on the back side, you have them in your notes. Tan x, I kind of squeeze it in there. Tan pi over 4. So this was an alpha and this is the beta. You come down, we're going to do the math. Tan x stays tan x. Tan pi over 4 is 45, which goes to 1. And then we replace these. Final answer, tan x minus 1, 1 plus tan x equals this. And because addition is commutative, check.